Now we are going to study the new section relations. Consider two sets P equals set A, B, C and Q equals the set Ali, Bhanu, Binoy, Chandra and Divya. I am going to write P cross Q. You know what is P cross Q? P cross Q is the Cartesian product of P and Q, in which it is a collection of ordered pairs in which the first element will be from the set P and the second will be from the set Q. A Ali, the same way the second element will be A Bhanu, the third one is A Binoy, next is A Chandra, etc. In this way, if you continue, the last element will be C Divya. Can you say how many elements will be there in this P cross Q? Here, number of elements in the set P equals 3 and number of elements in the set Q equals 5, which implies number of elements in the Cartesian product P cross Q will be equal to 3 into 5, which is 15. Thus, if you continue writing, you will get 15 ordered pairs within P cross Q. Now, in this P cross Q, I am going to define a relation R. Define a relation R in such a way that R equals the set of all ordered pair X, Y, such that X is the first letter of Y. X is the first letter of Y. This is the relation I am going to define. X is the first letter of Y. X will be from the set P and the second element Y will be from the set Q. This is the relation I am going to define. Which are the elements in the ordered pair or which are the elements in P cross Q which satisfies this relation? It consists of the elements R equals the ordered pairs A Ali, A Bhanu you can't take. Why? Because X is the first letter of Y. So in this way, if you continue, you get B Binoy, B Bhanu, C Chandra, this much only. Why? Because there is any element in P as D, so you can't connect with the Divya. So this much only. So R is actually a subset of P cross Q. R is a subset of P cross Q. Am I right? Only selected elements from P cross Q which satisfies this relation. X is the first letter of Y. This is a relation in P cross Q. Thus you can say that the relation R is a subset of P cross Q. Now I am going to represent the above two sets pictorially. Within the two sets, P equals set A, B, C, that I am going to mark this first oval, and Q I am going to mark the second oval. P elements are given to a set. The first element is A, the second element is B, and the third element is C. And in Q, we can mark the elements as Ali, Bhanu, Binoy, Chandra, Divya. Now, as per our relation, I am going to connect the element by means of arrow. A is actually connected with the Ali. B can be connected with the Bhanu, as well as B can be connected with the Binoy. C can be connected with the Chandra. This pictorial representation of the relation is called as an arrow diagram. So arrow diagram is a visual representation of a relation. Now you know that the relation R equals the set A Ali, B Bhanu, B Binoy, C Chandra. These are the elements in the relation. I am going to mention some important points regarding this arrow diagram. The set of all first elements, the collection of all first first elements. I am going to collect the first elements only. Which are the first elements? A, B and C. These are the first elements in the above relation. First element in the relation R. This is called as the domain of R. Domain of a relation. Very important. Domain of a relation R is the collection of all first elements in a relation is called the domain. Then I am going to write the second elements in the ordered pair. The second elements in the ordered pair are in the relation. Which are the second elements? Ali, Bhanu, Binoy and Chandra. These are the second elements in the relation R. The set of or the collection of the second elements in the relation R is called as the range of R. Remember these two important points, a range of R. So range means the collection of second elements in a relation, and domain means the collection of first elements in a relation or the ordered pair A cross B. Now the whole set Q, this whole set Q means the set Q which consists of Ali, Bhanu, Binoy, Chandra and Divya. Binoy, Chandra and Divya. This is the set Q. The whole set Q is called as the codomain of R. Codomain of R. Don't be confused with these terms once again. The first element of a relation R is called as the domain of the relation R. The second element in the relation is called as the range of R, and the whole set Q itself is called as the codomain of this relation R. So from this you can say one more point that this second element Ali, Bhanu, Binoy, Chandra. Ali, Bhanu, Binoy, Chandra. The second element or the range of R is actually a subset of Q. So at another point is the range of R, the range of a relation R is actually a subset of the codomain of R. Codomain of R. Very important are these points. Once again, a relation, what a relation is? A relation is a subset of the Cartesian product A cross B. A relation is derived from the Cartesian product by describing a relationship. Here the relationship is set of all x, set of all x, y, set that x is the first letter of y. This is the relation. X is the first letter of y. This is the relation. So, relation is obtained or derived by describing a relationship between the first and second elements in a Cartesian product. The collection or the set of all first elements in an ordered pair, the relation is called the domain. The set of all second elements in the ordered pair in a relation is called as the range of R. The whole set Q is called as the codomain of R. One more point, a range of R is a subset of the codomain of R. Note on these points. A definition of a relation. A relation R from a set A to a set B is a subset of the Cartesian product A cross B. This is very important. The relation R is a subset of the Cartesian product A cross B. Keep in memory, relation is a subset of the Cartesian product A cross B. A relation is derived from A cross B by describing a relationship between the first and the second elements of A cross B. The set of all first elements of the ordered pair in a relation is called the domain of R. The set of all second elements of the ordered pair in a relation is called the range of R. The whole set B, the second set, the whole set B is called the codomain of R. Range is a subset of the codomain. Try to keep these points in memory. I am going to do the problems based on relation. First question. Let A equals the set 1, 2, 3, 4, 5. Define a relation R from A to A by R equals set of all ordered pair x by such that the second element y equals the first element x minus 1. Y equals x minus 1 is the relation. X and y both are the elements of A. Why? Because The relation is defined from A to A. The relation R is defined from A to A itself. The condition is that the relation given is y equals x minus 1 is the relation defined here. The first piece, depict the relation using an arrow diagram. So, before depicting the element using the arrow diagram, if you want, you can write the relation R as R equals the set of all ordered pairs x, y in which y equals x minus 1. This is the relation given for. Both are the elements, both x and y are elements of A. Now, which are the elements which comes under the relation R? X as 2, then y comes as 1. Am I right? Why? Because y, the second element y equals the first element x minus 1. Here, you can't write the first element as 1. Why? Because then the second element will be 1 minus 1, which is 0, which is not an element in A. So, I am going to write the value of x as 2. When x becomes 2, what happens to y? Y equals 2 minus 1, which is 1. When x becomes 3, y becomes 2. When x is 4, y becomes 3. And when x is 5, y becomes 4. These are the only possible elements in the relation R. Before depicting the relation in an arrow diagram, try to write the relation in this way. So, R equals set of all ordered pairs 2, 1, 3, 2, 4, 3, 5, 4. Second question you can write now itself. Write down the domain. What is domain? Domain equals the set of all first elements of the relation. First, which are the first elements? 2, 3, 4 and 5. Domain equals the set of all first elements in the ordered pairs of a relation. What is range? Range equals the set of all second elements in the ordered pairs. Which are the second element in the ordered pairs? 1, 2, 3 and 4. So, range equals 1, 2, 3 and 4. But what is codomain? Codomain of the relation R equals, what is codomain? Codomain is the full set, the second set of y itself. What is the relation here? The relation is from A to A. So, the second set element A itself equals 1, 2, 3, 4 and 5. Remember, codomain is the full set which is on the right side. But range is actually the elements which can be connected. Now, I am going to depict the relation using the arrow diagram. The relation is from A to A. So, full elements of A you need to write 1, 2, 3, 4, 5. Here also 1, 2, 3, 4 and 5. The relation is from A to A. Now, I am going to connect it. 2 is connected to 1. Because the relation is y equals x minus 1. The second element y equals first element x minus 1. Then look at this and then draw. 3, 2. 3, 2, 4 is connected to 3. 5 connected to 4. So, this is the pictorial representation or the arrow diagram. Remember, 1, 2, 3, 4 is the range. But the full set A is the codomain. 1, 2, 3, 4, 5 is the codomain. Remember, the range 1, 2, 3, 4 is actually a subset of the, look at this one, the range is actually a subset of the codomain. Come with the next question. Determine the domain and range of the following relation. A relation is given for you. Relation R equals set of all ordered pair x with the x is an element of n. N means the natural number set n. Y element of the natural number set n. And x plus y equal to 10. This is the condition. Both x and y are natural numbers. Which are the elements we can connect in which x plus y equal to 10. Both x and y are natural numbers. 1 can be connected with 9. 1 and 9. Their sum will be 10. X, y. X and y. So, their sum x plus y will be 10. 1 plus 9. Their sum equals 10. In this way, write the natural numbers on to 8. Then the next element 3, 7. Another element 4, 6. Then 5, 5. Their sum is 10. 6, 4. Their sum is 10. 7, 3. Their sum is 10. 8, 2. Their sum is 10. And 9, 1. The sum is 10. So these are the members in the relation. Now you are asked to find the domain and range. Domain equals the collection of first elements in the ordered pair of a relation. Which are the first elements in the ordered pair? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the domain is 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now you are asked to write the range also. A range equals the collection of all second elements in the ordered pair of the relation. Which are the second elements? 9, 8, 7, 6, 5, 4, 3, 2, 1. Try to remember one thing as it is a set. If any repetition will happen, you must not write that element. In this question, you are not asked about the codomain. Can you say what about the codomain in this case? You know that codomain is the right shade set. Which is the right shade set? The set of natural numbers. So if you are asked to write the codomain is actually the set of natural numbers. The full set on the right side, that is codomain. Come to the next question. Determine the domain and range of the relation R equals set of all ordered pairs x, x plus 5. X is an element of the set 0, 1, 2, 3, 4, 5. You are given with a set 0, 1, 2, 3, 4, 5. You need to write the relation R. R equals, the first element will be x. I am going to write 0. Then the next y will be 0 plus 5, 5. The first element, if I take as 1, it will be 1 plus 5, 6. 2, 2 plus 5, 7. Then that is the first element plus 5 gives the second element. 3, 8, 4, 9, 5, 10. This much only you can write. Why? Because the first elements are x, which are x are 0, 1, 2, 3, 4, 5. So this much only you can write. Now you are asked to write the domain and range. Domain equals the collection of all first elements 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. What about the range? A range equals the collection of all second elements in the relation. 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10. Come to the next question. A relation R is defined from a set A equals 2, 3, 4, 5 to a set B equals 3, 6, 7, 10. Two sets are given for you. A equals the set 2, 3, 4, 5 and another set B equals the set 3, 6, 7, 10. Given the relation R as R equals the set of all ordered pair x, y such that x divides y. The first element x will divide the second element y. Express the relation R as set of ordered pairs and determine the domain and range. That is our question. I am going to write the relation R as the collection of ordered pairs. 2 divide 3 is not possible, so you can't write. 2 divides 6, it is possible. 2 divides 6. Why? Because x divides y is the relation. Then 2 divides 7, not possible. 2 divides 10 is possible. That comes as a member in the relation. 3 divides 3, possible. 3 divides 6, that also possible. 3 divides 7, impossible. 3 divides 10, impossible. So they can't come under the relation. Next element 4. 4 divides 3, not possible. 4 divides 6, not possible. 4 divides 7 also impossible. 4 divides 10 also impossible. Divide means completely divisible. Now come with the next element 5. 5 divides 3, impossible. 5 divides 6, impossible. 5 divides 7 also impossible. But 5 divides 10 is possible. So the members in this relation are 2, 6, 2, 10, 3, 3, 3, 6, 10, 5, 10. Now you are asked to write the domain and range. Domain equals the collection of all first elements in the relation. 2, again a 2, no need to write, repetition not allowed. 3, again a 3, no need to write. 5. So domain consists of the elements 2, 3, 5. Now you are asked to write the range. Range equals the collection of all second elements. The second elements are 6, 10, 3. Again a 6, no need to write. Again a 10, no need to write. So this is the range. 3, 6, 10 or 6, 10, 3. If you are asked to write the codomain, this question doesn't mention about the codomain. Codomain. What is the codomain? In this case, codomain is the right set B. The relation is defined from the set A to the set B. So codomain is the right set B, which is 3, 6, 7 and 10. I hope all of you understand how to do the problems based on relation. A relation will be actually a subset of the cross product, but the elements which satisfy the given condition only comes under the relation R. Homework exercise 2.2.